All right, lesson 10.2 is all about operations with radical expressions. Now, by operations, we basically just mean adding and subtracting them. So to add and subtract radical expressions, the radicands must be the same, just like the variable part of a monomial must be the same when adding or subtracting like algebraic terms. So by that we mean normally you can't add x terms with y terms. All the x's stay together, all the y's stay together. Well, same thing with square roots or our radical expressions. Square roots of 2 goes with other square roots of 2's. You can't put them together with square roots of 3 because they're technically different numbers. The square root of 2 is a little bit smaller than the square root of 3, so we wouldn't combine those together. The radicand does not change when adding or subtracting like radical expressions. Just add or subtract the coefficient of the radicands, or the whole radical piece. So again, what that means is, in a case like this, 5 square roots of 2 means that it's 5 times the square root of 2, 5 times whatever that answer is. 6 square roots of 2 is 6 times whatever answer that is. So we can put these two together, 5 of them and 6 of them. But this is actually saying take away 6. So when we tried to simplify this, it'll look a little bit different. So when we go through the whole example, simplify each expression. Example 1, each of these has the same radical. We have a root 2, and root 2. So we can put all of these together. In a way, it's like thinking about each of these as the same variable, 5x minus 6x plus 7x. If we called them all x, 5x minus 6x plus 7x, we could see that we would just be able to combine them together. Now, instead of calling them x, we'll keep calling them square roots of 2, and we're just going to add these coefficients, the 5 minus 6 and the positive 7. What that looks like is just 5 minus 6 plus 7 comes out to 6. So our coefficient part is going to be 6, but it's 6 what? 6 of what thing? Now if we called all these x, we'd call it 6x. So we're putting all of them together. We're not calling this piece x, we're calling it square root of 2. So our final answer here would be 6 square roots of 2. We can put 5 square roots of 2 together with 7 square roots of 2, and that would make 12. 5 and 7 is 12. And then we are taking away right here 6 of those square roots of 2, so it leaves just 6 square roots of 2. So that's how that would look. For example 2, we've got 4 different terms here, 15 square roots of 3, negative 14 square roots of 5, I call it negative because we have a minus here, 6 square roots of 5, because we have plus for positive, and negative, in a sense, you can think of it as 1, negative 1 square roots of 3. Or you can just think of it as minus the square root of 3, because 1 times the square root of 3 is just the square root of 3. So when we look at this, again, we need to put together just like terms. So this 15 square roots of 3 can only couple with another square root of 3. That would be right here. This negative square root of 3. Or again, remember, that's like saying minus 1 square root of 3. Now, we can also put together our square roots of 5. So this one right here, 14 square roots of 5, and this 6 square roots of 5. We're adding it on. So what these two are going to look like, our 15 minus 1 becomes 14. So that would be 14 square roots of 3. Our negative 14 plus 6 becomes negative 8. So that's negative 8 square roots of 5. So when you put it all together, it's 14 square roots of 3, take away 8 square roots of 5. Now again, because this is 3 and this is 5, these can't combine. They also cannot reduce anymore. We can't simplify square root of 3 and square root of 5, so this would be our final answer. Let's go on to some more difficult examples then. Sometimes we'll need to simplify each radical term first, if possible, and then perform the operations necessary on our like radical terms. So for example 3, we've got negative square root of 2. You can think of it as minus 1 square root of 2, minus 2 square roots of 18, plus 3 square roots of 8. Now as of right now, 2, 18, and 8, none of these match up, so we wouldn't be able to combine anything. But if we look at our terms, negative 2 square roots of 18, this middle piece right here, we can break up. Square root of 18 is the square root of 9 and the square root of 2. Square root of 9 we recognize to be 3. So negative 2 times 3 is negative 6. So this whole piece changed to negative 6 square roots of 2. Now let's move on to this next term right here. Oops. This 3 square roots of 8. That can be changed to 3 times square root of 4 times square root of 2, because we can break 8 down into 4 and 2. Now again, we recognize square root of 4 comes out to be 2. So 3 times 2 times the square root of 2 becomes 6 square roots of 2. So we've changed our middle term and our last term. So now this whole expression looks something like this. Negative 1 square roots of 2 minus 6 square roots of 2 plus 6 square roots of 2. This middle term was right here. This last term was right here. Now we can recognize they all have the same radicals. They're all square root of 2. So when we try to put them together, we just add the coefficients. This negative 1 from here, negative 6 from here, plus 6 from here. So negative 1 minus 6 plus 6 equals negative 1. So you'd call it negative 1 square root of 2, or you really don't even need that 1 part there. You can just call it negative square root of 2. Either one of these would be fine as your final answer. Let's look at example 4. We've got 3 terms again. Negative 2 square roots of 54 minus 3 square roots of 12 minus 2 square roots of 3. Now again, 54, 12, and 3, none of them match, but we can simplify a couple of these. Negative 2 square roots of 54 is the same as negative 2 times the square root of 9 times the square root of 6, because 9 times 6 is 54. So we recognize that 9, or square root of 9, is actually 3. Negative 2 times 3 is 6 times the square root of 6, so it's negative 6 square roots of 6. Now looking on to our next term, negative 3 square roots of 12 is negative 3 times the square root of 4 times the square root of 3, because 4 times 3 is 12. We recognize that square root of 4 is actually just 2, so it's negative 3 times 2 times the square root of 3. Well, negative 3 times negative 3 times positive 2 is negative 6, still times the square root of 3, so negative 6 square roots of 3. So we changed our first and our last, or middle terms. This last one is a square root of 3. That doesn't break down any, so we don't need to worry about simplifying that one. So, moving right along, this first piece became, right here, negative 6 square roots of 6. This second piece became right here, negative 6 square roots of 3, or minus 6 square roots of 3. And the last piece stayed as minus 2 square roots of 3. Now, we're going to look for ones that match. Square root of 6, square root of 3, square root of 3. These two match. So we can put them together by adding those coefficients. Negative 6 and negative 2 become negative 8. This piece stays the same, negative 6 square roots of 6. But now, instead of taking away two different terms, we're combining this into just one, minus 8 square roots of 3. So your end answer there, in most simplified form, is 6 square roots of 6 minus 8 square roots of 3. When we are multiplying radical expressions, this is going to be similar to multiplying algebraic expressions. Now, the radicands do not have to be like radicands when we're multiplying, only when they're adding and subtracting. So you can do x times y, and that'll make a new term, an xy term, but you can't add your x terms with your y terms. Same thing here. Our square roots can multiply together, but they just can't add and subtract together. If it's a monomial radicand expression multiplied by another one, you just multiply the coefficients and multiply the radicands. Then simplify if you can. But if there's adding and subtracting, you'd have to use the distributive property. So either if it's one radical piece times a binomial of radicals, then you would have to just distribute. If it's two binomials, though, you'd have to double distribute, or remember that would be called foiling. The FOIL method can be applied to radical expressions if you have a binomial radical expression multiplied by another binomial radical expression. And we'll see examples of all of those. So for example 5, you can see we have two terms. We've got 2 square roots of 6 times 7 square roots of 3. So it's just two monomial pieces being multiplied together. This piece times this piece. So like they said, all we do is multiply the whole number parts, or the coefficient parts, 2 and 7. That would give us 14 right there. Then our radical parts, we take square root of 6 times the square root of 3. Well, 6 times 3 is 18. So right now we're going to call it 14 square roots of 18. From here, we see if we can break it down any. So square root of 18 becomes the square root of 9 and the square root of 2. And we recognize that the square root of 9 is just 3. So it's 14 times 3 times the square root of 2. Square root of 2 does not simplify. So we just put it all together as, oops, wrong direction there. 14 times 3 is 42, still times the square root of 2. So 42 square roots of 2. That would be your final answer. In this case, we would distribute. Again, we can see a couple different terms. Square root of 15 is one of them. Square root of 3, but this square root of 3 is inside of the parentheses added with another piece. That other piece, the square root of 10, makes this a binomial. It's all of this together, like this. Everything inside this parentheses makes it a binomial. There's two terms in here multiplied by one out here. So in this case, we'd have to distribute. We'd have to do square root of 15 times square root of 3, and also square root of 15 times square root of 10. If we did square root of 15 times square root of 3, we'd get square root of 45. If we did square root of 15 times square root of 10, we would get square root of 150. Now from here, this is where we break things down. Square root of 45, you can think of it as like a 1 on the outside here. So 1 square root of 45 is 1 times the square root of 9 times the square root of 5, because 9 times 5 is 45. 9, like before, we recognize as being 3, so it's 1 times 3 times the square root of 5. We'll call it 3 square roots of 5. Now, square root of 150, we can also break down. We'll call it 1 square root of 50, which breaks down into 1 times the square root of 25 times the square root of 6, because 25 times 6 is 150. Why did I use 25? That's the biggest square number on our list of all square numbers that would come out of 150. We can recognize that square root of 25 is actually just 5. So 1 times 5 times the square root of 6 is now 5 square roots of 6. Putting this new expression, the square root of 45 plus square root of 150, and then replacing this one here and this one here, putting that all together means our final answer is going to be 3 square roots of 5 plus 5 square roots of 6. Now again, we can't combine these because square root of 5 and square root of 6 are different numbers. And also, square root of 5 doesn't break down anymore, square root of 6 doesn't break down anymore. So this is our most simplified answer. Now we're on to example 7. This is going to look real similar to the one we did before. We've got monomial on the outside, just one term. We've got two terms on the inside, 4 and square root of 6. So monomial and a binomial we need to distribute. This is going to be a little different because this one is a whole number, not a square root. So when we distribute square root of 10 times 4, it just becomes 4 square roots of 10. When we distribute square root of 10 times the square root of 6, it becomes the square root of 60. So right now, this is my expression after I distributed. Now I need to simplify. 10 will only break down into 2 and 5, and neither of those are square numbers. So we can't break it down into any simpler pieces. So this term is already as simple as it'll get. Square root of 60, though, we'll call it 1 square root of 60, we can break down into 1 times the square root of 4 times the square root of 15. We took out 4 because that was the biggest square number out of our whole list. Now square root of 4 we recognize as 2. 1 times 2 is 2 times the square root of 15 2 square roots of 15 is our new second term. So that takes the place of this one here. Replacing this for our second term there, our whole new expression is now 4 times the square root of 10, that was here before, plus, instead of square root of 60, we simplified it to 2 square roots of 15. So this would be our final simplified answer. Now, for example 8, we can see that we have 1, 2 terms in this piece. So inside this parentheses, there's a binomial. Also over here, 1 and 2 terms as well. So it's 2 binomials. This is when you have to do the foiling. Now remember, when you FOIL, it's first, outer, inner, last. So we have to do our first terms first. 3 square roots of 2 times the square root of 2. When you do that, you are going to get 3 square roots of 4. Next one we would do 3 square roots of 2 times square root of 3. This is going to give us positive 3 square roots of 6. This is positive, this is positive. Positive times positive makes a positive, so plus. Now we have to do the inside ones. So negative 4 square roots of 3 times square root of 2. Remember, I have to call it negative because there's a minus here. So negative 4 square roots of 3 times square root of 2 becomes negative 4 square roots of 6. This root 3 and this root 2 multiplied to make root 6. And lastly, we have, let me get another marker out, negative 4 square roots of 3 times the square root of 3. So this one coming over here, which means we're going to have negative 4 square roots of 9. The square root of 3 times the square root of 3 is the square root of 9. Now, before we start simplifying anything else, we see right away square root of 4 is just 2, so this is 3 times 2. Square root of 9 is just 3, so this is saying negative 4 times 3. So, first simplifying that away, this becomes 6. 3 times 2 is 6. This becomes 12. 4 times 3 is 12. Or think of it as minus 12, negative 12. So these two whole number pieces have come out of those two. We simplified it. Now we need to look at these. Notice square root of 6 and square root of 6 in both cases. When we combine them then, we're just looking at the coefficients, positive 3 and negative 4, which means it would combine to negative 1. Positive 3 minus 4 is negative 1. So it's 6 minus 1 square root of 6 minus 12. We're not quite done yet though, because if we take 6 and combine it with negative 12, we can simplify that whole number part and we'd get negative 6 minus 1 square root of 6. Or you don't even really need that 1, you can just call it negative 6 minus the square root of 6. Either one of these is going to work just fine. And this is going to be your final simplified answer. And our last two examples. For example 9, we're going to simplify again. We're going to need to use our FOIL method like before. So negative 4 times 3 gives us a negative 12. Next we would do negative 4 times positive square root of 5. So it would be negative 4 square roots of 5. Next we're going to do the inside ones. Positive square root of 5 times a positive 3 becomes 3 square roots of 5. And lastly we have positive square roots of 5 times positive square root of 5, which is going to leave us with square root of 25. And I called it 1 square root of 25, just because. You can call it, you put the 1 there if you want, you don't need it there if you don't want it there. But in a sense, there's a 1 in front of this and there's a 1 in front of this. Now, to start simplifying this down, we're going to do two things in one step. First off, square root of 25 we recognize as 5. So this is 1 times 5. This piece, negative 4 square roots of 5, plus this piece, positive 3 square roots of 5. Negative 4 and positive 3 combine to make a negative 1. So this is going to be negative 12 right here, minus 1 square root of 5. 1 times 5 makes our 5 right here. So negative 12 minus 1 square root of 5 plus 5. We're almost done. all we have to do is combine our whole number parts, the one without any radicals, so negative 12 and positive 5 would combine to negative 7. So you can either call it negative 7 minus 1 square root of 5, or just negative 7 minus the square root of 5. Either one works. And now we're on our last example. This one, it says, in a binomial, 3 minus the square root of 5, that whole thing is squared. Now, because there's a 2 on the outside, or it's a squared, don't think that you can just do squared to each one. That only works if these were being multiplied. These are not being multiplied, they're being subtracted. So when we do this, we have to think, what does squared means? It means times by itself. So I want you to write out the problem so it looks like this. 3 minus the square root of 5, all in parentheses, times another 3 minus the square root of 5 in parentheses. Now we can see that it's two binomials, so we'll have to FOIL. 3 times 3, 3 times negative square root of 5. Those two would leave us with 9 and negative 3 square roots of 5. Next we would do negative square root of 5 times positive 3, and negative square root of 5 times another negative square roots of 5. And remember, there's kind of a hidden 1 in front of each of these. So like negative 1 times negative 1. So when we do those, negative 1 square roots of 5 times 3 becomes another negative 3 square roots of 5. Negative 1 square root of 5 times negative 1 square root of 5 leaves us with positive 1, because negative times negative is positive, so plus 1 square root of 25. Now like before, we can recognize square root of 25 is just 5, so we'll call this 1 times 5. This whole piece, this term, is 1 times 5. We can also recognize that we have negative 3 square roots of 5 that match with another square root of 5. It's another negative 3. So negative 3 minus 3 more leaves us with negative 6. So 9 minus 6 square roots of 5, and then plus 5. In the end, we need to combine our whole number pieces, this 9 and this 5, and we would get 14. So we'd have 14 minus 6 square roots of 5. And that would be our final answer. And that'll actually complete it for our 10.2 lesson.